Assalamualaikum and hello. We are going to continue the subtopic 4.2, which is stoichiometry in this part. So basically, we've done with 4.1 chemical equation. Now I'm going to introduce to you about stoichiometric calculation, where we are going to understand how to calculate based on stoichiometry in terms of mass, in terms of volume of gases, and in terms of volume and concentration. And in this subtopic as well, we are going to learn how to define limiting reactant, theoretical and actual yield, and percentage yield by using a simple calculation to find the value for them. So let's get on with the first one about the learning outcomes of this subtopic, which I already introduced to you in the slide before. So what I'm going to focus in this video, we are going to calculate the stoichiometry based on mass. But before that, we are going to understand bits of stoichiometry calculation. First thing first, you have to know what is a stoichiometry. So stoichiometry is a term that can be used to calculate quantities such as amount of products that can be produced. What we call in another term adalah dalam bentuk yield. So bila saya bercakap tentang yield, dia bermaksud tentang amount of products, and sometimes we use it in terms of percent. So that's why you've been introduced with the term percentage yield. And the next one, stoichiometry calculations also can predict the components diluted in a standard solution reacted in the experimental conditions. So this is what you are going to learn during your lab session and also in this chapter about how to calculate based on the diluted of standard solution. This is illustrations how the stoichiometry works. So first thing first, you've known that this is the definition for the stoichiometry. A quantitative study of reactants and products in a chemical equation. So maknanya kita akan relate both of them all together to find a final answer. Next one, kita ada dua condition di mana condition yang pertama, if reactants are reacted in exact stoichiometric proportion, maknanya semuanya reacted completely in a chemical reaction. So maknanya awak akan kehabisan reactant. Semuanya digunakan untuk menghasilkan semua produk yang awak dapat dalam stoichiometric proportion yang sama. Tapi another one more condition, if the reactants are not reacted in exact stoichiometric proportions, so apa yang terjadi, kita akan ada dua keadaan. Keadaan yang pertama, one reactant is completely consumed in the chemical reaction dan another one more reactant is not completely consumed. So maknanya kita ada reactant A dan B. For example, one of them is going to be limiting reactant di mana dia completely consumed sebab dia punya amount limited. Tapi another one more is not completely consumed, kita panggil sebagai excess reactant dan dia dalam amount yang besar. So inilah yang akan remains at the end of the reaction. However, limiting reactant kerana amount dia sedikit, dia completely consumed, dia memang limited dan amount of product pun akan limited. Dan at the end of the reaction, dia tak ada baki seperti mana excess reactant. So that's how you want to understand about stoichiometry. The first thing first. Now we are going to learn how to calculate based on stoichiometry. So for example, I have this equation. Di mana saya ada dua reactant. Yang pertama CaCO3 dan another one more HCl. These two are my two reactants, and then I got from here both reactants react together to produce my products. Ada tiga, iaitu calcium chloride, carbon dioxide and also water. So kalau saya nak emphasize dalam bentuk ayat, saya akan menggunakan coefficient yang dia ada di hadapan ni, di mana coefficient ini kita akan gunakan sebagai mole. So what I can say that 1 mole of CaCO3 reacts with 2 mole of HCl to produce 1 mole CaCl2 plus 1 mole CO2 and 1 mole H2O. So itulah yang kita guna in terms of stoichiometry, relationship antara reactants dan juga products. Dan kita akan compare based on coefficient dekat hadapan. Coefficient ini akan wujud if you got the balanced chemical equation. Kalau chemical equation tu sudah balance, maknanya coefficient dia akan satu lah, sentiasa satu, where you don't have to change anything. Tapi kalau dia belum balance, maybe some of the compounds awak akan tambah coefficient. Contohnya HCl di sini, originally dia adalah HCl, tapi apabila kita ingin balancekan semua equation, kita akan tambah 2 coefficient dekat hadapan, dan 2 ini mewakili 2 moles. So itulah yang kita akan gunakan dalam kita punya calculation. So from here, we are going to use stoichiometry to calculate any species that we are interested during chemical reaction. So for example, let's try example 1, how to calculate based on stoichiometric calculations in terms of reacting masses and moles. So what I have here, I got my question. How many moles of hydrochloric acid, HCl, is needed to react with 0.5 moles of zinc? And you have to determine the mass of HCl. So what I'm going to do, daripada ayat ni, benda pertama, I have to do my equation. So in order for you to do the equation, sometimes the compound is given in the chemical formula. This is what we are going to use. Tapi sometimes dia tidak beri, contohnya zinc. So you have to determine what is the element or chemical formula for zinc. So inilah apa yang awak akan apply daripada chapter 2. You have to put it here. So what I'm going to do, I'm going to put my equation where I got my reactant HCl reacts with zinc. So I got here both of them, and when both of these react together, I need to determine the products form. So I got here H plus and Cl minus, and then saya ada zinc 2 plus. Bila kita nak react, kita akan react antara ion tu untuk hasilkan compound. So ion yang opposite, zinc 2 plus akan react dengan Cl minus. So I will have zinc chloride, and then the rest of it, saya ada 1 hydrogen, dia akan combine with another hydrogen untuk hasilkan hydrogen molecule. So this is my product. So ini equation saya yang original. But before you want to start to do the calculation based on stoichiometry, you have to make sure your equation is balanced. So what I'm going to do, saya balance where I have to put 2 HCl. So that's it. This is my balance equation. Now, what I'm going to do next, saya akan keluarkan information one by one that is given from the question. And saya juga keluarkan information apakah yang saya perlu cari. So now, soalan saya tanya how many moles HCl. So, maknanya moles untuk HCl saya perlu cari. And the next one is needed to react with 0.5 moles of zinc. So, maknanya moles untuk zinc sudah diberi 0.5 mole. Saya tulis dekat bawah compound tersebut. And the next one, another one more question, I have to determine the mass of HCl. So, another one more question is mass of HCl. So, how to do this? Benda pertama, walau macam mana pun, you have to find the mole. Itu adalah stoichiometry calculation. So, I have to find the mole between 2 compounds yang kita ada, HCl dan zinc. So, maknanya, what I have to do, this is it, the stoichiometric calculation. Benda pertama, kena tulis perkataan from balance equation. Perkataan ni wajib ada untuk kita buat comparison. So, stoichiometric calculation, kita akan compare antara HCl dan zinc. So, now, what I'm going to do, saya akan ambil coefficient yang ada untuk 2 comparison compound kita, HCl dan zinc. So, zinc ada 1 mole dekat depan. So, I put zinc first. So 1 mole zinc reacts with 2 mole of HCl. So nilai 1 dan 2 mole ini datang daripada coefficient balance equation. And the next line kedua, kita akan tentukan apa yang kita sudah ada, iaitu zinc. Saya ada mole untuk zinc. So, I put 0.5 mole zinc reacts with mole yang saya nak cari untuk HCl. I will put X. So, itu nilai yang kita nak cari, X mole of HCl. So, what I have here, so untuk line pertama, as I mentioned before, this is from equation yang sudah balance. And the next one, line kedua, inilah stoichiometry. Tapi syaratnya mesti dalam terms mole. Okay? Seperti mana yang awak lihat. Dan kita akan buat comparison. So, apa yang kita nak cari adalah X. So, now I'm going to do darab silang. Di mana X akan darab dengan 1. 0.5 akan darab dengan 2. So, what I have here, this is it. Saya rearrange my darab silang. Saya jadikan X sebagai saya punya subjek, benda yang saya nak cari. So, I will have the value for X is 1.0 mole. Tapi, kena sebut of siapa? Of HCl dalam case ini. So, now I got the moles for HCl here. And then, seterusnya saya kena calculate mass. So, saya dah ada mole, of course, I can calculate the mass. So, gunakan formula yang awak belajar untuk cari number of mole berdasarkan mass. So, rearrange that. Saya ada mass of HCl di mana 1.0 mole of HCl yang saya dapat daripada X akan darab dengan molar mass of HCl. So, I will have 36.5 gram of HCl. So, inilah cara di mana kita gunakan stoichiometric calculations in terms of mass and moles. And, satu term yang awak kena faham, saya gunakan sama dengan yang ada 3 titik dekat sini, as you can see here. So, ini adalah simbol untuk menunjukkan bahawa reacts with ataupun produces. So, maknanya dalam stoichiometry ni kita akan gunakan simbol inilah. Kebiasaannya awak akan selalu nampak. Dan tips yang saya nak emphasize here, you have to make sure you balance the equation first before answering the stoichiometry. Because kalau equation awak salah, maknanya untuk line pertama ni awak dah salah. Sebab ini bergantung kepada equation yang sudah balance. Okay, next one, kita try one more example. So, I got example 2. Masih lagi in terms of mass and moles. So, this is my question. How many moles of H2O will be formed when 0.25 mole of C2H5OH burns in oxygen? And you have to calculate the mass of water. I know there are a lot of information here, but first thing first, before awak keluarkan information, buat dulu equation. So, I got here, apa yang saya tahu, how many moles of H2O will be formed. So, maknanya H2O akan berada di bahagian produk. And then, saya ada 0.25 mole of C2H5OH. Ini adalah ethanol. Dia burns in oxygen. So, maknanya saya faham ethanol dan oxygen reacts together as my reactants. So, saya ada C2H5OH plus O2. And the next one, saya nak hasilkan H2O sebagai saya punya produk. Tapi, we have to understand organic compound, another product yang akan terhasil bila kita buat combustion selain water adalah carbon dioxide. So, I have CO2 plus H2O. So, ini konsep mesti strong. Sebab you have to know how to do the equation. Because sometimes ada soalan yang tanya macam ni. Okay, now I got the equation. So, what I'm going to do next, saya perlu balancekan equation saya. So, how to do that? Saya balance dulu method. Gunakan apa yang awak belajar 4.1 inspection method. Carbon saya ada 2. So, I put 2 here. And then the next one, I got hydrogen sebanyak 6. So, I put hydrogen here 3. And saya akan balancekan oxygen. So, saya ada 1 dan sini ada 2. Total dia adalah 3. And then here, saya ada 2 darab 2, 4, tambah dengan 3 oksigen, 7. So, untuk saya tambah dekat sini, saya akan tambah 3. So that total sebelah kanan 7, total sebelah kiri pun 7. Okay, so itu adalah equation saya yang sudah balance. Now, I'm going to take out all the informations given. So, how many moles of H2O? Itu soalan saya yang pertama. So, moles untuk H2O. And the next one, I got 0.25 mole of ethanol. So, 0.25 mole ethanol, saya tulis dekat bawah dia. And the next one, I have to calculate the mass of water. So, mass. Okay. So, that's how you take out the information. Now, kita akan tentukan comparison antara dua benda. Dalam kes sebelum ni, dia adalah antara reactant dengan reactant. Sekarang, kita ada comparison antara reactant dengan produk, iaitu ethanol dan H2O. So, how to do that? As usual, gunakan satu perkataan special untuk stoichiometry from balance equation. Dan ada dua line. Line yang pertama based on equation awak. So, kita ada 1 mole of C2H5OH dan saya ada 3 moles of H2O. So, that is my first line. It means that 1 mole ethanol produce 3 mole H2O. And then, next line adalah berdasarkan apa yang diberi. So, apa yang diberi, dia hanya berikan mole untuk ethanol. So, I put 0.25 mole of ethanol dan apa yang kita nak cari adalah mole untuk H2O. That's why I put X here. And then, darab silang, rearrange your equation. X is going to be this form. And then, awak akan dapat nilai dia 0.75 mole H2O. Pastikan tulis mole untuk siapa dekat at the end. Okay, and then settle untuk soalan pertama. Saya dah calculate moles untuk H2O. And the next question, I need to find out the mass. So from the moles, I can calculate the mass of H2O where I times with 18.0 gram per mole. Molar mass for water. And then my answer is going to be 13.50 gram. So settle for the second questions. And as I mentioned before, you have to make sure that you balance the equation first before you answering the stoichiometry. So that's all how you want to calculate based on stoichiometric calculations in terms of reacting masses and moles. Dan basically bila kita buat stoichiometry, benda pertama yang kita kena faham adalah moles. So, gunakan formula yang awak sudah belajar. So, saya ada a bit stoichiometric pathways di mana apa yang diberi dengan apa yang kita mahu cari iaitu X. Basically, kita akan belajar dalam 3 terms. Mass, gas volume dan molar concentration. Tapi, at the end of the day, kita akan compare antara mole ratio. So, everything must go through moles. So, that's all for this video. I hope you've learned something. And you can try to do the tutorial questions to enhance your understanding. Please do the tutorial so that you can know what went wrong and what goes right. So that's all from me. Thank you for watching.